part, to our lightning notes. If you saw the notes that I posted and got them printed, then you have a few blanks to fill in. If you don't have them printed, and you can fill them in on the computer, that's fine. Finally, the option is you just take them on paper. Can you see my screen? So we're going to look just briefly at how lightning works, and hopefully what we'll be able to see is a similarity between how nature works when creating lightning and how you just made static electricity, because lightning is based in static electricity. So we're going to just kind of go through a list of steps. So step A says that raindrops in a cloud, so we have to picture raindrops in a cloud. Raindrops in a cloud are not static, meaning they don't just sit there. So they fly past one another because there's air currents moving within a cloud, especially a big storm cloud. We say raindrops fly past one another and they collide into one another. So raindrops fly past one another colliding. And as they slide past one another, what's created? So if these are two raindrops sliding past each other, what's created? What did you create? What do we fill in this blank here with? Oops. Sounds like a lot of us have a case of the Mondays. So I'm just going to pause. Maybe we have questions on capital letter A. But if I get silence on that, then I need somebody to help us out with this blank here on capital letter B. What is this? What am I trying to gesture here? What are we creating when something slides past something else, whether it's wool on a plastic tube or a balloon on hair or two water drops sliding past each other? What are we making? What are we creating?
Static
electricity.
There's eventually, yes, but we don't get static electricity without friction. Friction is a force that exists in nature that can remove electrons. As they slide past each other, they create friction. So as we move on to capital letter C, now we start to venture towards the idea of static electricity, where one portion of the cloud becomes negatively charged like the wool, while the other part of the cloud gets a positive charge, like the tube, or like the spoon, or like the balloon, whatever we use. Capital letter A, just for review, raindrops fly past one another and they collide. So that collision effect, that sliding effect for letter B, we wrote the word slide here. As they slide past each other, friction is created. And friction is ultimately the force that even in your demonstrations, friction was the force responsible for removing electrons from one thing and adding them to another? Good question. Any other questions? We're through letter C.
Could you repeat letter C?
Yeah. The most important part to get out of letter C is simply that one portion of the cloud becomes negatively charged and the other portion of the cloud becomes positively charged. So as we transition to letter D, we're going to get that key vocabulary term again, split up here, but it's the word polarization. The ground has had nothing done to it. All the action is going on in the cloud that's above the ground. But the ground starts to have its positives drawn to the surface and its negatives repelled. So anytime we attract an opposite and repel a like charge, we use this word polarized. We say the ground becomes polarized until what happens? We can only charge the cloud so much and polarize the ground so much until what happens? I'm on letter E. What would we see in nature?
Lightning.
You would see a spark, and that's your bolt of lightning. And sometimes it's really dramatic and dangerous, and sometimes it's within the cloud itself and really quick and not as dangerous. But basically what you did in your demonstration was a mini version of what happens in Mother Nature. Anytime you scuff your feet across the floor and then go touch a door handle, you're creating a spark of lightning. Anytime you get out of your car and you touch the door handle and you get a shock, that's exactly what's going on with lightning. Nolan, did you have a question?
No, I didn't mean to do that.
Okay. Capital letter C says one portion of the cloud becomes negatively charged like the wool. Now this goes way back to our notes last week where I charged up a plastic tube and I used some wool and some plastic. We said the other part gets a positive charge, like the plastic tube. Yeah, exactly, Carson. Same thing. Anytime that there's movement, friction, sliding, you're removing electrons from one thing and adding it to another. But I guess the other idea here is that nature can only handle that separation of positive and negative for so long, and then we get a spark. And everything goes back to equal. We use the word, I don't know if you've heard it before, but we use the word equilibrium. Nature likes to be in a state of balance. We would say for letter D that the ground, I'm going to show you a picture here that you can choose to get into your notes if you'd like. The ground would have its positives drawn to the surface. Let me try and show you with this picture. So here's my big storm cloud, and there's raindrops. What kind of, raise your hand. How about this? Raise your hand if you could tell me what kind of cloud I've attempted to draw here.
Cumulonimbus.
Raise your hand. Caleb.
Cumulonimbus.
Yes, thank you. We have a cumulonimbus cloud, a really tall cloud, and there's a lot of collisions, millions and millions and millions of collisions between raindrops. Lots of friction occurs. We add electrons from one thing and remove them from another. the big point is I want you to know this black line is meant to split the cloud in half from top to bottom. The bottom becomes negatively charged. The positive becomes, the top becomes positively charged. And then we get this idea here. So now somebody besides Caleb, raise your hand if you can tell me what word goes here. So here's the ground and here's a little guy standing here. Positives are being drawn towards the surface. Negatives are being repelled. Raise your hand either digitally or physically if you can tell me what word goes in this blank. Leah.
Polarization.
Awesome. Yes, we need the word polarization here. The ground becomes polarized. Just like the sugar that Steve used became polarized. Just like the can that, oh, who did I drop in and I saw? It was Ella and who else was in that room, Ella? Is that?
Elise.
Yeah, it was Elise at the time. Anytime we're attracting the opposite and repelling the like charge, we use the word polarize. And again, nature can only exist in this state for so long, and we get this bolt of lightning, this energy, where everything goes back to normal. And then it happens again. And the more violent the storm is, the quicker it happens. So that's the gist of lightning. Hopefully you're comfortable with the idea of static electricity. And hopefully you're able to properly use the word polarized. As we start to wind down today's lesson, your task is to turn in your visual display, whether that's a picture of the page you used or the Google Doc that you used. In addition to giving you some participation points for being in the breakout rooms and sharing your demonstration, I want to see your understanding of it. Are there any questions on what you need to turn in? Are there any?
So do you just want us to turn in the paper that we described what we were doing on?